The embryo at the 9th day. Now we can see the metamere clearly. Within the heart, blood is beginning to flow, little by little. You can see hemocytes flowing along the dorsum of the embryo. The direction of the flow has gradually become more definite. Around this time, blood cells begin to flow toward the head of the embryo too. The blood flow around the head increases rapidly. The red blood cells which were created in the yolk sac are large and all have nuclei, unlike the blood cells that can be seen in the mature adult. The red blood cells at this stage are called primitive erythrocytes, and it becomes clear that they can also be produced independent of erythropoietin. Platelets can be seen here, mingled with the red blood cells, but they exhibit a primitive form, not seen in the adult. Now we are also able to see cells which are thought to be granular leukocytes attached to the vascular walls. It may be that these leukocytes attach themselves at the prenatal period like this because they're learning how to act during an inflammation. The embryo at the 10th day. Blood flow toward the head has increased rapidly, and the capillaries have begun to develop. The manufacture of endothelial cells of the blood vessels has gradually become more distinct. Around this time, the number of primitive platelets increases rapidly, and we can see many cells, thought to be leukocytes, and other cells attaching themselves to the blood vessels. The embryo at 10.5 days. The blood vessel, deep in the center, is the vitelline artery. Behind this is the AGM region. The AGM region consists of the three parts, the aorta, the gonads, and the mesonephros. The differentiation of blood cells does not occur here, but it has recently come to light that this region generates hemopoietic stem cells, which are the origins of all blood cells. We remove the AGM and created an organ culture. Cells, which appear to be stem cells, are multiplying in great numbers. In order to discern whether these are hemopoietic stem cells, we sorted them according to surface antigens, which indicate multipotential stem cells. In doing this, we were able to confirm that the CD34 positive, c-KIT positive, and SCA1 positive cells are able to form colonies even on their own. We also found out that with 10 of these cells, it is possible to completely replace the bone marrow of an adult mouse. This proves that the hemopoietic stem cells exist in and are multiplying in the AGM region. However, we also understood that although the adult hemopoietic stem cells are CD34 negative, the same cells in the AGM are positive. What does this mean? Attention is being given to this new way of understanding the hematopoiesis in the AGM. From this photograph, we surmise that blood cells are also being generated in the vascular endothelium of the AGM. After purifying the vascular endothelium and carrying out a further experiment, we were able to prove that blood cells are being generated from the endothelial cells in the blood vessels.